In this lecture, we discuss the concept of BFSK modulation, or how when we have a binary data sequence of zeros and ones, how we are able to obtain the BSK waveform that is represented by two frequencies, one that is F1, the other one that is F2. F1 is higher than F2, and therefore we want to find out how do we obtain this. And we say now that, as you can see this diagram, the binary data sequence is passed through a bipolar non-return to zero encoder. What that does is that it gives us a pulses of positive signal and zero signal, or 0 volts. Positive volts, positive, maybe positive 5 volts, or and 0 volts. 0 is for when there is zero, simple 0, and positive 5 volts is when we have simple 1 in the binary input sequence. The output of the bipolar non-return to zero encoder is applied to two independent balance modulators, that is 1 and 2. This is the one that we call product modulator. It just does multiplication. And this balance modulator has two inputs. The input from the NRZ encoder and an input from the local carrier oscillator that is generating, one of them is generating frequency at omega 1, and the other carrier oscillator is generating carrier frequency or carrier signal that is centered at omega 2. So the top one will produce F1 that is either, you see, when we have ones and zeros, and we are multiplying this 1 and 0s or level encoded signal with a high frequency, what is going to happen is that at this point, when you multiply a very high frequency like that, at the output of that modulator, we are going to have that signal, and then when it is multiplied with 0, it just goes to flat. Then when you multiply again, you're going to have this high frequency component, and then when it is, so this is the one that comes here, and then it is 0 again, it becomes 0, of course, flat. So at the top output of the balance modulator, you're going to have that one. But you know, there's a step here that I believe that might have been skipped, and I will check in my notes. We normally have inversion that happens here. We invert the sequences of zeros and ones, such that if we had positive 0, positive 0, then it is inverted to become opposite of what it is, so that the zeros become ones and ones become zeros. And therefore, when we multiply with the modulator M2, the zeros are going to generate the lower frequency component, because we are going to be having zeros coming here. How these zeros, probably I may just draw here. Assume I have just drawn well. We are multiplying this signal now, which is the inverted input signal. Then you multiply it with a little lower frequency, carrier frequency with omega 2. And therefore, at 0, we simply cut off. Well, when we have a 1, which is now representing a 0, we are going to have lower frequency component. And when we have a 0, which is now representing a 1, which we have inverted, it becomes flat. So what we are going to find out is that let me just try to finish this. So when these two are added, so we have this signal that is representing F2 or omega 2, and we have this signal that is representing F1. When they are added, they are going to be a different time instance. So when this was 1, it was changed to become 0, and therefore the other one will become lower frequency component that is represented by F2, and the other one, these two were high, therefore these are going to become 0, and this one will become high again, and therefore they're representing as 0. So what we are going to end up with is that when we add this one with this one, we are going to have a one continuous signal that is having two frequency components that are similar to this one. So one of them is lower frequency, F, maybe F1, I can't remember which one I said is the F1, and the other one is F2. And they are coming at alternate intervals. They are never appearing at the same time. That is how we generate the BFSK.